Dear students, now we have seen second part of instrumentation of infrared spectroscopy. Contents of this PowerPoint slide is instrumentation parts. Already in first part we have seen two instrumental parts. In this slide we have seen three instrumental parts, that is, first is sample holders, means sample cell and sampling of substances. Next instrumental part, detectors, and last instrumental part is recorder. Now we have seen next part in the instrumentation of IR spectroscopy as per sequence is third instrumental part is sample holders or sample cell and sampling of substances. As solvents used to prepare sample solutions have the tendency to absorb the infrared radiation, sample cells or sample holders are usually of much narrower, means 0.1 to 1 millimeter, than the one used in visible or ultraviolet region. The sample cells are usually constructed using pickle salt and sodium chloride, means pickle salt means sodium chloride. The sample cells are demountable and Teflon spacers are used along with sample cell to adjust the path lengths. Fixed path length cells are also available and they can be filled or emptied with hypodermic syringe. As the sample cells are made up of alkali metal salts, they become foggy due to moisture and thus they need polishing with buffing powder to render them useful again. The sampling of the substance in infrared spectrophotometry depends upon the state of the sample, that is, whether it is gas, liquid, or solid. Depending upon the nature, various sampling techniques have been developed and used. Now we have seen sampling of solids. Solid whose infrared spectra are to the recorded can be sampled in various ways. These ways are in which first way is solid dissolved in solvent. The solid samples are usually dissolved in a suitable solvent and this solution is used in one of the cells. This method cannot be used for all solids because suitable solvents are limited in number and generally no single solvent is transparent throughout the infrared region. Second way is as solid film. In this technique, sample solution is placed on the surface of a potassium bromide or sodium chloride and the solvent is allowed to evaporate. Thus, the solid sample forms a thin film on the surface of cell. This technique is useful for rapid quantitative analysis but not for quantitative analysis. Third way is Mol technique. In this technique, the solid sample is mixed with heavy metal oil, means nuzol, to form a paste. This paste is then sandwiched between two salt plates and then used for spectral measurement. Although nuzol is transparent and in most parts of the infrared region, but it has absorption maxima at 2915, 1462, 1376 and 719 per centimeter. This is the drawback in using nuzol for certain compounds which may have absorption in the region similar to nuzol. This technique is mostly used for qualitative work and not for quantitative estimations. Fourth way is pressed pellet technique. It is also called as disc method. This technique is frequently used for qualitative work. In this, a small amount of finely ground solid sample in the form of dried is intimately mixed with about 100 times its weight of powdered potassium bromide. in a small agate pestle mortar. This mixture is pressed under a high pressure, means 25,000 psi per gram, in an IR tablet press to form a small pellet or tablet. The resulting pellet is transparent to infrared radiation and can be used as such. This technique has some advantages over the Newjoul-Mool method. First advantage, it eliminates the problem of bands which appear in IR spectrum due to use of Newjoul. Second advantage is the potassium bromide pellet, if preserved properly, can be reused for recording the spectra if required again. And third advantage, the resolution of spectrum in potassium bromide pellet is superior to the one obtained in Newjoul-Mool technique. Now we have seen sampling of liquids. The samples that are liquids at room temperature are usually handled in the pure form and free from moisture in the form of thin layers in variety of absorption cells. Various types of cells like sandwich cell, demountable cell and cavity cells are available for handling liquid samples. These cells are made up of sodium bromide, potassium bromide or thallium bromide. In demountable cell, the salt plates are usually separated by a gasket and held together by a clamp. Now we have seen sampling of gases. Gas samples are examined in infrared region after removing the moisture or water vapors. The dried gases are introduced via a stopcock and a system whereby a partial pressure of about 5 to 50 millimeter of mercury can be applied. The gas sample is introduced into the gas cell, which is made up of glass or a metal cylinder of about 10 centimeter long. The end walls of the gas cell are made of sodium chloride. For measuring very low concentration of gases, long pass cells are required. However, the sampling area of most spectrophotometers is restricted in length. Now we have seen next instrumental part is detectors. There are two types of detectors used in IR spectrophotometry. First is thermal detectors and second is photodetectors. We have seen firstly thermal detectors. When the infrared radiations falls on these detectors, they cause heating which gives rise to a potential difference which is measured. This potential difference depends upon the amount of radiation. The thermal detectors commonly used are thermocouple, bolometer and thermistors and Gole cell or Gole detector. Firstly, we have seen thermocouple. It is the most commonly used detector in IR spectroscopy. Thermocouples are basically the dissimilar strips of metals joined together at one end. Now we have seen bolometer. They are constructed from metals or semiconductors. In this, large change of electrical resistance depends on temperature. When the radiations falls on bolometer, there is temperature change which causes change in the resistance of the conductor. Now we have seen thermistors. These function similar to bolometer. They are the resistors made by fusing several metallic oxides. These show a negative thermal coefficient of electrical resistance. Now we have seen Gole cell or Gole detector. Gole cell is nowadays used in several commercial spectrophotometers. It consists of a small metal cylinder, one end of which closed by blackened metal plate and the other with a metallized diaphragm. And second type of detector is photon detector. Photon detectors are widely used in near-infrared region. They consist of suitable semiconductors like lead sulfide, lead telluride, or germanium, which are non-conducting at lower energy state. Now we have seen recorder, last instrumental part of IR spectroscopy. In infrared recording spectrophotometers, as the sample absorbs some energy, the sample beam and reference beam differ in their radiant energies. Then detector system generates the signal which is normally amplified and goes to servometer. The servometer, which is connected to attenuator comb, blocks the part of reference beam till energies of reference and sample beams are equal, and thus beam balance is achieved, that is optical null. The attenuator comb is tied mechanically to the pen of the recorder and paper driver. They are synchronized with the automatic rotation of wavelength mirror. The transmittance of the sample is recorded as a function of wavelength. Thank you.